All right, so chapter 4, we're looking at matrices. And we are lumping these first two sections together because they're very easy. So 4.1 and 4.2. 4.1 is talking about everything that's on this first page here. So you'll want to write down this sentence because I'm going to ask you the dimensions of a matrix. We always label the size with the number of rows and then the number of columns. So write down these two matrices. We're going to use them in the examples down below. And in that first matrix, that's a 2.1, not a 16 in the middle. It's 2.1 and then 6 and then 0. So if we're listing the number of rows first and then columns, the size of that one is a 4×3. Those are the dimensions. We always go in that order, never the other way around. So looking at example 2, what are the dimensions of that one? 2×5. Okay, the other thing that they want you to know in 4.1 is how to name an element. Instead of saying, find the number 1, but I don't want the one on the left, I want the middle on the bottom. There's a much easier way and more organized way to do that. This number, -3 right here, is in the third row, the second column, so we label it like so. So if you don't have the notes, this is the important information to write down. That's how you name an element. If it's in the third row, second column, we put the 3 and the 2 in that order kind of as a sub number down below the A. And again, it's in the same order as what we were looking at for the dimensions. We always do the row first and then the column. So if we're looking at example 2, what position is the element that is 7? The row is 1, the column is 3. So it's not really A13. You're looking at the two numbers separately. So it's the first row, third column. And the last example. Looking at the left matrix, what position is 0 in? Mm-hmm. Questions on that? That's everything in 4-1.
That pretty much as hard as it's going to get. All right, I like this section.
Does anyone still need this?
Don't curse us.
This is the second row, third column. That's where this 0 is.
If you had like that example on example 2, position of 0, would you label all those?
They wouldn't ask you for 0 because there's multiple ones. They would they would use it the other way and say element that's in a 2-2. Oh, okay. They would say it that way. We all know we're talking about the same number.
Okay.
All right. So this right here, that middle row got moved over. So when you're copying this down, it should be like this. All right, so the second thing that we're going to be learning is adding and subtracting matrices. Now you may remember from last year, we had a couple of sections on matrices. where when you add and subtract, you just add and subtract the elements that are in the same position. So the upper left corner gets added or subtracted with the upper left corner, and so on and so forth. And we can only add and subtract matrices that are the exact same dimensions. So you can't add a 2 by 2 to a 4 by 2 because you need the same position to add with the other one. Just be careful if you are subtracting that you actually subtract. So if you're subtracting a negative, it turns to adding. So the first term would be 6 because you're taking 4 minus negative 2. And hopefully you're able to easily fill in the rest of this. So we've got negative 3, negative 7, 0, and what's the last row?
115.
Isn't it 114? 114. Questions on adding and subtracting? It's a nice chapter to end the year with. The last thing before we try a couple of examples is also review. This is scalar multiplication. Whenever you have just one single number outside of a matrix, what should we do? Yep, just times it by everything inside. So it's kind of like distributing. So we've got 9, 15. That would be your answer. Now, when we do the test, it's going to be formatted like it's going to be on the next slide. So that's the main reason why we're going to go through some examples. I'm going to give you a bunch of matrices across the top, and then underneath it, I'm going to ask you to do things to them, like add them, subtract them, multiply them, things like that. Anyone still need this? Okay, so this is what the test is going to be formatted like. It's going to have matrices across the top, so if you could copy down those 3, because then we're going to have questions like this. So after you write those down, we can find those answers. Mm-mm.
Excuse me, learning?
So when you see that 3a minus 5b, that 3 is that scalar multiplication. So it really looks like this, 2, 3, 0, negative 1. And then we've got a 5, and we put matrix B here. So that's the setup of this problem. We'll actually distribute these with the scalar multiplication. So we've got this as our first matrix. Now we're only distributing the 5 here, not the negative 5, so we'll keep that minus sign in between. So we've got negative 20, we've got 35, 25, and 20. And then all we do is subtract those 2. So help me out here. What's our answer?
26.
Negative 26. So that would be your answer, and that's what I'm looking for on the test as far as work. One left. 2a plus 4c. So let's set it up. We've got 2 multiplied by a. Hold that thought. What did you say, Alex?
Can't do it because they're not the same amount, but layouts.
Not the same layouts. What do you mean?
That one's 2 by 2, that one's 2 by 3.
And this one's 2 by 3. So you wouldn't have anything to add to those numbers, correct? We can't do this one. It is impossible. No solution. So you do need to watch out for that. Size of those matrices have to match.
Should we still write it down though, or just say no solution?
You can say no solution.
Okay.
Questions?